Well, thank you for posting here. I hope to use this for you guys to talk to each other, help each other. So this was great. Okay, let's zoom in. You're very close on this one. Negative 1/2 cosine x. So using Desmos, you would have had a graph very similar, but some key differences. This right here, because of that negative, would actually flip down here. And you would get this lovely mirrored graph, right? So it would be something, oh boy, here we go. Oh boy. Anyway, it would be like a mirror. See how the purple line is reflected across the x-axis? That's pretty cool. That's what the negative on the outside of the function does. Okay? So that's why that one is a little bit off. Some of the key features, we talked about this last week. If we have the y-axis and the x-axis, cosine, and we'll use red, will start up here. It'll go down and then back up and repeat itself, right? Cosine would cross the x-axis at pi over 2. Its minimum should be at pi. Come back across the x-axis at 3 pi over 2. This is like the unit circle and those criticals. And then finish at 2 pi. By finish, I mean complete one cycle before repeating itself. Let's use a different color. Let's use blue. Watch, see this? If we go down and go back up, peak to peak, 2 pi is the period. And then after that point, it's just going to repeat itself over and over again. I know, it's a terrible sine wave. Desmos is great. Okay, so that's talking about this one, which I think is question number 1. You guys might have different variations, but that's what's happening here. So you were really, really close. You have to look at the y-intercept when you use Desmos back to our course. You have to think about what each of the parameters do. Where does sine start, cosine start? Because we haven't done any vertical shifts yet, and we haven't done phase shifts, which with a phase shift, you can actually make the sine function look just like the cosine function. You just got to move it to the left or the right, and then they're exactly the same. Anyway, okay, so hopefully that answered that one. Moving down. What is the frequency of this sinusoidal graph? Frequency, I think, is question, I don't remember what question number it is on today's quiz 106. But here, I know it's going to be really hard to see. We need to first find the period from the graph. So we talked about that way back in quiz 102. In order to find the period, you start here, you follow it. This is a sine function, so that's great. That is correct, so good job. The amplitude is 3. Well done. But the period is off, which means our B value is off. So you nailed it. You nailed A. Excellent. You've got the sine function. Perfect, because it starts at the origin, and our sine function starts at the origin. We need to figure out Bx is in order to figure out the frequency if we had the equation. But in this case, they want us to use the graph. So now the period, you got the amplitude, you got your min max, you picked the right graph. Now we need to go figure out the period. So let's finish tracing it. I know it's very, very blurry, but that should say pi over 2. That should say pi over 2, right? That's what it looks like to me. 0 to pi over 2, and it completed one cycle. So the period is pi over 2. That's the period. Okay, how does that help me? It's not asking for the period, Mrs. Reynolds. I know. It's asking for the frequency. Well, the frequency is just the reciprocal of the period. So if P equals pi over 2, the frequency will equal 1 over P, which is just fancy notation for the reciprocal. So just flip it, which will be 2 over pi. Does this make sense? That's the relationship between the period and the frequency. They're just reciprocals of each other. And in science class, the frequency is like how fast are the waves coming, usually in units of time. So we would say that many pass in a second. 2 over pi waves pass in a second. Something like that, depending on what your units are. So the context matters. You're learning just the math and how to read these graphs and waves, right? That's what we're practicing right now. These waves have a application in real life, a representation in real life, and the context matters. So depending on that, but frequency, how often, how frequent, hey, how frequent do you come here? How frequent do you practice math? Frequency, kind of the same thing when it comes to these waves. Anyway, all right. Hopefully that makes sense, but the frequency is 1 over the period, and the period is however long the distance it takes to complete one complete cycle, right? So it doesn't repeat itself. So from 0 to pi over 2, after that, it will just begin to repeat itself. And in fact, every pi over 2, it will repeat itself no matter where you start, right? Even if I started here, and I go down and back up to the next peak, that will still be, if we find the distance, pi over 2. The period doesn't change depending on where you start. So if you started here, you found all of the points before it repeated itself, and you stopped, that's going to be pi over 2. Okay, all right, let's keep going. So good job. That's excellent. It shows a lot. So let's see. So if pi over 2 is the period, then the frequency is the reciprocal 2 over pi. I know it's blurry, but it says 2 divided by pi. Okay, so now that we talked about the period, how to find it graphically, how to find it when we're given an equation, well, B, the parameter B, affects the period or changes the period, which in a for graph translations and transformations, has to do with horizontal stretch and compression, right? With horizontal stretch and compression. Well, we're going to talk in terms of the period. The period is equal to 2 pi over b, where b is found in the form cosine of b times x or sine of b times x. So if you're given this, then you just plug it in. So in our case, our b is 2, but that's not our period. So now we need to substitute it in. 2 pi divided by 2. These just cancel. It equals pi. Thank you for asking and posting here. Great questions. Hopefully these answered yours and some of your classmates. Keep them coming. Keep that thinking. Keep trying. Reach out to me if you want these points back. Just respond that you watched this video, that it makes sense to you, and I will gladly add points back. Test corrections, quiz corrections, checking our thinking is how we learn and grow. So always do it. Reach out. I'll try my best to respond as soon as I can. So thanks for watching.